Okay, here are two examples that I want to show you guys. Now, what is the degree of this numerator right here? The 1. The degree equals 1, and that's important to know. That's your n. Remember the previous slide I showed you guys? What's the degree of this denominator? 2. So the degree of this one is 2. And so here, the case that we have here, n is less than m. The degree of the numerator is less than the degree of the denominator. So what does that mean? What is our horizontal asymptote? The HA is y equals 0. And it's important to be able to identify your asymptotes, because when it comes time to graph it or to get an idea of where our graph is, you need your asymptotes. They give you an idea of what your graph is going to look like. So here the horizontal asymptote is y equals 0. So what does that mean in terms of your graph? That means on your graph at y equals 0, it's kind of hard to see. I'm trying to draw a line like right next to it. That's where your horizontal asymptote is. That means your graph will not cross that line.
But it can cross the other one.
Well, we haven't identified our vertical asymptote yet. For our vertical asymptote, what you have to do is you take the denominator and set that equal to 0. So we have 3x squared plus 1, and we set that equal to 0. Alright, so to solve this, because there's only one x term, I'm just going to solve it using inverse operations. So I'm going to subtract 1. I have negative 1 and 3x squared. I divide both sides by 3, and I get negative 1 over 3, and we have a negative number. So what does that mean? Well, when I try to square root, I can't square root that unless I want to get an imaginary number. So this means that there are no vertical asymptotes for this one. No vertical asymptotes.
How come? Because that doesn't work?
Yeah, because you can't do this. Okay, can you think of a number that you could plug in right here that would give me a 0 for the denominator?
What if it
No. And actually, because of that, it changes the way this asymptote behaves. If you look in the book, it has a graph of it, or you guys could throw this into your graphing utility. The graph of this looks something, I think it's like this. It's kind of different. But don't take my word for it. Throw it into a graphing calculator to take a look at it. Okay, so this one's kind of weird, the first one, but the next one not that weird. Okay, the degree for the top is 2. I should say d equals 2, and the degree for the bottom one is d equals 2. Okay, so the degrees equal. So in this case, the n equals the m. Okay, the degree of the numerator equals the degree of the denominator. So what does that mean for our horizontal asymptotes? You always check the degrees for the horizontal asymptote. So let's see, HA. So my horizontal asymptote, what's my horizontal asymptote going to be? Well, it's going to be y equals the leading coefficient from the numerator and divided by the leading coefficient from the denominator. So this it's going to be 2 divided by 1. Because your leading coefficient for the numerator is 2, the leading coefficient for the denominator is 1. And so what's my horizontal asymptote? Y equals 2. Yeah, let's clean it up. Y equals 2. So when I go to graph it, it looks something like this. Let's see, there's my line, there's that line. Okay, actually let's move that line up a little bit. Okay, so at y equals 2, which is right there, we have a horizontal asymptote. Actually, I don't want you there anymore. Okay, so now what about our vertical asymptote? Now this is more normal. You'll see more denominators like this one. We're going to take that vertical, or the denominator right there, and set that equal to 0 to find our vertical asymptote. So we're going to take, say, x squared minus 1 equals 0. And to solve this one, I know some of you guys are looking at it and go, oh yay, factor it. Yeah, you could do it that way. That way works. You'll get the same answer as me. I'm going to use inverse operations. So x squared equals 1. And I have to square root both sides, so I get x equals plus or minus 1. You always get a positive or and a negative when you square roots when you're inside of an equation. Because if you square positive 1, you'll get 1. If you square negative 1, then you'll also get 1. So you have to have both those answers. So what does that mean? That means we have 2 vertical asymptotes. We have one vertical asymptote at negative 1, and one vertical asymptote at positive 1. Wow, this is kind of weird. All these asymptotes, what's this line going to look like? Now, if you want to find out what this line looks like, you're going to have to pick some x values. You're going to make a table of x values, unless you have a graphing utility, which is why graphing utilities are beautiful. If I want to see what the line looks like over here in this area, on this side of the vertical asymptote, I'm going to have to pick, let's see, what is that, -3? No, that's 2. -2. And also I'm going to have to pick -3 to get an idea. Because my line's going to look something like this. It's going to go like this, or it's going to go like this. I don't know which side it's going to be on. Is it going to be above my horizontal asymptote, or is it going to be below the horizontal asymptote? So if I plug in -2, what do I get? I plug in -2 to this bad boy right here. Let's see. Let's clear up some space and plug in -2. Let's see. We have f of -2. When I plug that in, I'm going to have 2, and -2, I'm going to square it, and then I'm going to take the -2, square it on the bottom, and then I'm going to subtract 1 from it. So for the top, I get 2 times 4. On the bottom, I'm going to have 4 minus 1, and that's going to equal 8 divided by 3. And that's going to be what? 2 2/3, right? So 2 2/3. Where is that on my graph? Let's see, let me write 2 2/3 here. 2 2/3. Is that above the horizontal asymptote or below it?
Above.
It's above it. It's actually right above it, right there. No, probably a little higher than that. Okay, so I know that the graph is going to be like up here, but it's going to hit that point and then go up. Okay, and if you pick -3 and plug it in, you'll find that you get a point that's right about there. And it's just an approximation. Now, to do the rest, you would have to continue to pick x numbers that are between the asymptotes, and then pick some x numbers that are on the right side of that far right asymptote. So let's see, if I picked a 0, which is right here, what would I get if I plug in a 0? Here, let's just change our work up here. If I plug in a 0, what do I get up here? Let's see, I'm going to plug in a 0 right there, and then right there. If I plug in a 0, that's going to be 0 on the top. Cool. And on the bottom, I get -1. What's 0 divided by -1?
0.
Oh, that's just 0. So if I plug in a 0, I get a 0. That means I have a point right here. And that means the bottom part of the graph is going to go like this. The lines just kind of hug the asymptotes. They get really close to the asymptotes. And then if I plug in 1, a positive 1 right here, you'll find that you get a positive 2 2/3 again. So your graph's going to look something like this. Sorry, I meant to say 2 1 2/3. So if I plug in a positive 2, I would get 2 2/3.